Hello class, this is second lesson of today's 7.4 integrate rational functions. So I know that you guys probably forget some of the stuff you learned in pre-calculus, okay? First, to integrate rational functions, we really have to do a partial fraction most of the time. Not all the time, but majority of the time you have to do a partial fractions. So how do you do it? You look at the pattern. If you have a fraction right here, right? This fraction can be breaking into two small parts. That is if the cube of x can be factored as x minus a, x minus b. Now only do two of them because it's easier for me. And if you have three of them, you just keep going a, b, c like that. That's the first pattern. That's the easy one. The second pattern is that if your cube of x is equal to x minus a and square, means you repeat the x minus a. Then you're going to start for degree 1, x minus a, and then go to degree 2. And then the tops are still a and b, just a constant. But the number 3, you have to be careful. Number 3, if you have a quadratic in the bottom, okay, this cannot be factored. It's only prime. It means that you cannot factor any further. So if a qs is equal to that pattern, so that's a qs. Then on the top, you have to go ax plus b. Okay, so 1 degree lower than that. And you can see on the top also 1 degree, constant, degree 1, constant, degree 1, constant, degree 1, constant, degree 1. This is degree 1, degree 2. Okay, you look at degree. And if you repeat that quadratic, then you have to do just like how you do number 2. You're going to start for 1 first, and then you go to 2. Okay? And then on the top, be a1x plus b1, a2x plus b2. And that's if a q of s looks like this. Repeating the 2 here. Now the last pattern is very useful, okay? The book didn't state it, but I tell the class, okay? If the degree on the top is bigger or equal, okay? The degree in the bottom, then use a long division first. So what I mean by bigger, so let's say if x squared plus 1 over x minus 1. So that's bigger. Or if I would like 2x plus 1 over x minus 1. So that's the same. Then this kind of thing, you use a long division to do it, okay? So this is basically 5 patterns. So now I'm going to use do some examples. So I'm going to erase this. Good thing about recording on the video, so even though I erase it, you can also go back to look at it again, okay? And we're going to start our problem number 1. The problem number 1 is problem number 12 on 7.4. Number 12. And they say integrate 0 to 1 x minus 4 over x squared minus 5x plus 6. First, this is dx right here. First, you're going to factor this one first. So you can see this can be factored into x 6, I think it's negative 2 and negative 3. Okay. So if you're not sure, you can check back. Okay, x squared, negative 3x, negative 2x plus 6. Okay, and then you put it on the side of 1 your partial fraction. Okay, so you go x minus 4, x minus 2, x minus 3. And because they all have a degree 1, so that is a pattern number 1. So you go x minus 2, put a here. X minus 3, put b here. Okay, so that's the pattern number 1. Now we're going to find the LCD. This is your LCD. LCD is the one before you break it. Okay, so that means you are missing ax minus 3. This one you are missing x minus 2. And your LCD is this. Once you get your LCD out and you fix your numerator, and then these can be gone. You don't need them anymore. So now you just match them. X minus 4 equal to ax minus 3a plus bx minus 2b. I'll multiply them, okay? I'll multiply this inside. And now we're gonna match them. The x match with all the x here, okay? The constant match with all the constant. So we have just the coefficient we're gonna match. So we're gonna have 1 equal to a plus b. Okay, that's the first equation. So you take this away. The second is a negative 4 equal to negative 3a minus 2b. And you're going to solve this system equation. You can just time by 2 here. Okay, time by 2. And you're going to have a 2, this new equation, 2 equal to 2a plus 2b. That's the new equation, the one I put red. Add them together, so that become negative 2 equal to negative a. Your a is equal to 2. So that's the first one. Okay, you get a equal to 2. Now you go back to here, get your b. So 1 equal to 2 plus b. So b is equal to 1. And so that means your a is equal to 2 and then b is equal to 1. So 2 and 1. Okay? So what do I do with it? So once I get here, and then, so I'm going to continue here, okay? I don't have enough room on the top. So these are my work here. So that become 0 to 1, 2x minus 2 plus 1, x minus 3. And this whole thing dx, well, that's easy now. That's just ln. Remember in class I told you guys, they add in a constant means nothing. So that's ln, 2 ln x minus 2 plus ln x minus 3 and 0, 1. So this whole thing 0, 1. So put the 1 inside here. So 2 ln negative 1. Okay, 1 minus plus ln negative 2. And then subtract, put the 0 inside here. 2 ln negative 2 plus ln negative 3. Okay, and you can see that that's the first part and second part. ln 1 just equals 0, so you can just mark this at 0 here. And that's equal to ln 2, come out the absolute just ln 2, minus 2 ln 2, okay, and then minus ln 3. It comes out equal to negative ln 2 minus ln 3. So that's for problem number 12. Oh, b is the negative 1. I'm sorry. This is, I make a mistake here. You guys telling me something, you make a mistake right here. sorry. I just noticed that. And b is equal to negative 1, so that means it's a negative. Okay? I bet you guys only caught my mistake. So that'd be negative here. And then that'd be negative. If I make a mistake, I apologize. In class, you guys also remind me. So that comes out equal to, when I put the 1 inside here, this is a negative here. Negative. And then this will become positive. So that's a 3. Okay? So that's a positive. Okay? So that's how you do problem number 12. And now we're going to try the one. I don't have a big whiteboard. I tried to buy it. None of them available now because the lot of school are closed. So all the supplies are just not there. So I can only use my daughter's little whiteboard. And let's look at problem number 24. Oh, number 24 here. we're going to integrate x squared subtract x plus 6 over x cubed plus 3x, and then dx. And you can see the degree on the top here is smaller than that, so we couldn't use a long division. Okay, we're going to factor first. X factor out, and then we have x squared plus 3. So pattern, okay, we're going to have for x squared minus x plus 6 over x squared plus 3. And the 5 pattern I give to you guys earlier, it can be combination of 2 patterns together, or 2 or 3 like that. So this one always a pattern number 1 and number 3, because it's a quadratic. So we're going to make this to be like this. And this is degree 1, so just put a constant on the top. This is degree 2, we have put a linear degree 1 on the top, so bx plus c. And your LCD just this. Okay, that's good about it. The LCD just that. So if you want to go quick, you just multiply this one by x squared plus 3, and this one by x. Okay, and these all white out. Okay, you don't need to worry about it anymore. And this will be x squared minus x plus 6 equal to, then you multiply the, distribute the ax squared plus 3a plus bx squared plus 3cx. And now we're going to pair them up. We look at the one with the x squared, okay, all the x squared together, just the coefficient pair together. So it's 1 equal to a plus b. So that's your first one. And then the second one, so these are gone. Okay. The second is x, and then x. Okay. So negative 1 equal to c. So c comes out right away. And then the last one, okay, so these are gone, is the constant. Okay. So 6 equal to 3a, and then a is equal to, now a is equal to 2. So once you get equal to, I'm going to put it right here. Okay, so 1 equal to 2 plus b. I'll be careful because you guys not in front of me, can, you know, remind me, so sometimes I make out a mistake, and then I really miss you guys in the class. So b is equal to negative 1. So once we get that, so we know that a is equal to 2. Okay, 2, and that is a negative x minus c, so minus 1, c is equal to negative 1. So I don't want to be so messy, so I'm going to erase this part. Plus I need more room too. Okay, so my new partial fraction, it becomes 2 over x plus a negative x minus 1 over x squared plus 3. And this one, when you integrate it, okay, we put back in the integration. So we put back the integration right in front of it. If I just rewrite it. This one, you have to be careful now because you couldn't use a u sub here yet, okay, because there are 2 terms here. So we're going to break this into 2 parts. So make it to be negative x over x squared plus 3, and then minus 1 over x squared plus 3. And then this whole thing dx. Well, this one can come out nicely. It's just equal to ln x. Okay. Subtract. Now this one they use u sub. Okay. So we're gonna break one at a time. So we're gonna integrate this one first. And we're gonna let u equal to x squared plus 3, and du equal to x dx. Okay, and then you only have this is dx here. Okay, x dx just equal to 1/2 du. So this becomes 1/2 du, and that's your u. So your answer equals 1/2 ln u. And that's same as a 1/2 ln x squared plus 3. So that is a 1/2 ln x squared plus 3. So that is for this one. This one is something you guys don't like. It's in the exam, right? Every time you have an x squared plus a constant, that is a formula for anti-tangent, okay? So I'm going to show you guys now. Every time you see 1 over x squared plus a squared, now this is a squared here, okay? Used to we see 1 most of the time, but now it's not 1, then what do? It comes like a tangent inverse x over a plus c, okay? So that's the formula. And so now this one is equal to 1. Well, we don't have a squared, right? We have 3. So what you need to do is write this as square root 3 squared. That's the same thing, right? So you got a minus 1 tangent inverse x over square root 3 and plus c. So that is, oh, I forgot the 1 over a in the front. The formula is 1 over a, like this. 1 over a tangent inverse x over a. So this is minus 1 over square root 3. Okay, so that's how I do these problems. And I know it's a bit long, yeah, but the process is not that bad, okay? So it's pretty easy to follow. And you just look at the video a few times until you get it. If you don't get it, feel free to send me a message on the discussion board and take a picture of the problem, tell me which portion you don't understand. I will upload to explain that part for you. Make sure you check the cameras all the time to make sure that I do upload something new. And I try to upload the video before the class, okay? So here's the problem number 26. We're going to integrate x squared plus x plus 1 over x squared plus 1 squared and d over x. And if you look at this problem, you realize that this is upon pattern number 4. Okay, pattern number 4 is when you have a quadratic and then square. So we're going to write out the pattern first, okay? Solve for the coefficient. So x squared plus x plus 1 over x squared plus 1 squared, and that's equal to x squared plus 1, and then you increase it, x squared plus 1 squared. And then you're gonna have ax plus b, and then cx plus d. So now be careful here, because most of the time I see students able to find the pattern, but they're not able to get the algebra out. You can see here these are two the same, but these are one more power. So that means you need to put one more, okay? One more this, and then you just put one more on the top. Okay, that's it. Now you're going to multiply out, okay, FOIL. So ax, like this FOIL, okay? So ax cubed, and then you can take out all these. You only use it, so you don't, then you just put x squared plus x plus 1 equal to ax cubed plus ax plus bx squared plus b plus cx plus d. And now you just match, well, there's no q here, right? So that's nice. There's no q here, means no one match with this one, so that is equal to 0. So your a is equal to 0, okay? Now we're going to measure b x squared. So you can see here 1 here. And you have for this one, b. So these are gone. So b is equal to 1. And for the x, you have 1 here, a, c. Well, because a is equal to 0, so c is equal to 1. So it's very nice. Okay, so 0, 1, 1. And the last one is for 1. 1 is equal to, let's see, I don't have this anymore. I don't have this, so b plus d. So b is equal to 1. And d is equal to what? 0. So that's very nice. Okay, so your a is equal to 0. B is equal to 1. So on the here, just equal to 1. Okay. C is equal to 1 and D is equal to 0. So this is just 1x, just x. So I'm going to erase this part because I need more room later on. So I'm going to erase this one. So this problem will become, okay, write this part will become 1 over x squared plus 1 plus x over x squared plus 1 squared. And then the whole thing d over x. See, you guys have seen here, now you cannot get away from tangent inverse, okay? So please memorize it because in the exam last time, point number 2, Dr. Sim forget about this. So please memorize it. This one used very often actually. And because it's a 1 here, so I don't need to divide anything. I don't need to, 1 over 1 just 1, x over 1 just 1. So now for this part, okay, this one you have to use u sub again. So I'm going to do right underneath here. And I'm going to let u, okay, let u equal to x squared plus 1 du equal to 2x dx. Somebody asked me, how do I know that's my u? As long as it's a chain rule there, then that's usually your u. And then I have x dx already, so I need to take away the 2. So I'm going to put it back. So my x dx equal 1/2 du. And this is my u squared. Okay? And this is equal to negative 1/2 1 over u plus c. How do I know that? Because this made this to be u to the negative 2. Okay, integrate u to the negative 2 just equal to u negative 1 over negative 1. And which is equal to negative 1 over u. And you can memorize that from now on because this one used very often. Okay, you memorize it. 1 over u squared du is just equal to negative 1 over u plus c. Okay, so now we're going to put back the u inside. The u is equal to x squared plus 1. So negative 2x squared plus 1. And so that's equal to minus 1 over 2 u squared plus, x squared plus 1. And then plus c. So that's for these problems. And the last part I want to do is point number 34. Before you two chop me off, so I have to make sure I finish in 30 minutes. I think maybe because so many people use YouTube now and then they limit your time to use. I don't know why it earlier wouldn't. Once I go 33 minutes, it just automatically stop. So, don't know what happened. Okay, so the last point in this session, I want to show you one. If you use a bound division, then what happened? Okay, number 34. If you have x to the 5th plus x minus 1 over x cubed plus 1. dx. Well, you can see the degree here is bigger than degree here, so you have to use a long division first. Okay, how do you do that? Divide it. Make sure you fill in the missing term. And it's an x cubed plus 1. Your goal is to take away the x fifth. Use this to guide you. Okay, so you ask yourself, x to the third times the what numbers equal x to the fifth. So x to the third times the what equal x to the fifth. Always is x squared. Okay, so that becomes x to the fifth. And then take the x squared times by 2 upon 1 also. So become x squared here. And subtract them. Okay, subtraction here. Okay, subtract. And then that becomes 0. This is all 0 here. This is subtract. It becomes negative x squared plus x minus 1. And then that's it. Because this degree is lower than that, you can just stop. So that means this one, it will become x squared, okay, plus negative x squared plus x minus 1 over x cubed plus 1. Now, once you get to here, don't be hurried to do partial fraction, okay? Factor this one first. This is x plus 1, x squared minus x plus 1. That's by the cube formula, okay? A cubed plus b cubed equal to a plus b, a squared minus ab plus b squared. That's the formula I use. And then I can notice that these two are almost the same, okay? All I need to do is multiply this whole thing by -1 and then -1 in the bottom, okay? And then you can see that that will become, now this will become x squared minus x plus 1. And then you notice that that's the same as this one. So you can actually reduce, okay? So this becomes x squared, not the minus 1 over, I still have the x plus 1, and then dx. And integrate that, it just equals 1/3 x cubed minus the ln x plus 1 plus c. So that's how you do problem number 34. So just be careful here, okay? Once you've seen here, don't immediately say, oh, I need to partial fraction, I'm going to break it. Don't break it. See if you can reduce first. If you can reduce, you reduce. If you couldn't reduce, then you use the pattern 1 to 4 to finish off. So that's all for today's lesson. Thank you. Make sure to do your homework. Don't delay it to the end, because once we go back to school, we have to prepare for our exam.